Internal rate of return. The internal rate of return, IRR, is the discount rate at which the project's NPV is zero. IRR calculations rely on the same formula as NPV does. However, IRR is not the actual dollar value of the project. IRR is the annual return that makes the NPV equal to zero. If the IRR of a project is higher than the cost of capital, then the project is profitable, feasible, and hence should be accepted. On the other hand, if the IRR is less than the cost of capital, then it should be rejected because it is not profitable. Without a computer or calculator program, the internal rate of return is calculated using a technique known as the interpolation method. The interpolation method produces an estimate of the IRR, although it is not arithmetically exact. The first step is to calculate two net present values, both as close as possible to zero, using rates for the cost of capital, which are whole numbers. Choosing rates for the cost of capital, which will give an NPV close to zero, that is, the rates which are close to the actual rate of return, is a hit-and-miss exercise. Several attempts may be needed to find satisfactory rates. Let's use an example using the IRR method. Assume a company is evaluating a project that will require an initial outlay of $5,000. Net cash flows from the project are: in year 1, the cash flow is $1,700. In year 2, the cash flow increases to $1,900. In year 3, the cash flow decreases slightly to $1,600. In year 4, the cash flow further declines to $1,500. And finally, in year 5, the cash flow drops to $700. If the company's required rate of return, which is the cost of capital from any project, is 15%, evaluate whether this project should be conducted. Use the discount factors 14% and 18% to estimate the IRR of the project. These factors are taken from the discount factor table. Trying with 14%. In year 0, the cash flow is minus $5,000, discounted at a present value factor of 1, resulting in a present value of minus $5,000. In year 1, the cash flow is $1,700, discounted at a present value factor of 0.877, resulting in a present value of $1,491. In the same way, we will calculate present values from year 2 to year 5. So after summing up the present values, the net present value of the project is $283. This is close to zero. It is positive, meaning the IRR is more than 14%. We can use 14% as one of our two NPVs close to zero. Now, in the same way, let's analyze the cash flows and their present values using an 18% discount rate. After summing up the present values, the NPV of the project is minus $142. This is relatively close to zero. NPV is negative, meaning the IRR is less than 18%. We will now use these two NPV values to estimate the IRR. The formula to apply is IRR equal to A plus NA divided by NA minus NB multiplied by B minus A, where A is the lower rate of return, B is the higher rate of return, NA is the NPV discounted at A, NB is the NPV discounted at B. Let us go back to our example. IRR equals 14 plus $283 divided by $283 minus $142 multiplied by 18 minus 14. This gives a value of 16.66%. According to the IRR method, the project would be accepted since the company's policy is to undertake projects which are expected to yield 15% or more.